This is our final product, the Luminary Improved Visibility Interactive Cycling Helmet by Sam, Joe, Carter, and Maddie. Our project goals for this product was to improve visibility for the biker at nighttime use, make it easy to use, and inexpensive for the user. The equipment that we had was one bike, a helmet, two Arduino Uno boards, two wireless shields, four 220 ohm resistors, one 10 ohm resistor, and lots of 26 gauge wire. We also needed two rocker switches, two momentary switches, and 40 LEDs for the helmet. In total, this project cost us $105.84.
On the helmet, there are three separate circuits connected to the Arduino board: the left blinker, the right blinker, and the brake light. Both of the blinkers have 11 LEDs connected in parallel. The brake light, however, consists of two portions, both connected in parallel, the top and the bottom. The grounds of all of these are connected through a 10 ohm resistor to the Arduino board. On the bike, there are four separate circuits, one for each of the brakes, and the left blinker and the right blinker.
Next, I'm going to talk a little bit about the code on the bike and load it into the Arduino boards. Now, the switches on the bike, depending on which ones were pressed, it would send a signal to the Arduino board. And then from there, that Arduino board would use the wireless shield to send a signal to the helmet. Based on what letter, because the code uses the serial monitor the helmet receives, it will turn on the corresponding LEDs. So for example, if it receives the letter B, it would turn on the brake lights. And here's an example of the different pins on the Arduino board that were needed for the switches on the bike. And then in the void loop, the state of all the switches was red from the bike. Next, what happened was it would look at what buttons were being pressed and then send the corresponding letter. So here you can see that if the brake was pressed but the right signals and the left signals were not pressed, send the letter B. The code on the helmet was similar. It started off by initializing all the pins that the LEDs needed to connect to, and then the setup loop also initialized the serial monitor and the different pins. The way the void loops work was if there was a letter sent, it would turn on the corresponding LEDs based on that letter. So here you can see that if the letter B was sent, it would turn on the brake, the upper and the lower, because we had two different circuits for the brake light. And yeah, that's basically how the code works. So now we'll just show you a quick.
Here's a demo of our final product. First we'll show you the brake light.
I watch the patchwork farm slow fade into the
And then the left turn signal.
from here. They can't see me stare at the stale
As well as the right turn signal.
recycled air. I watch
And then when both the left and right turn signal are turned on at the same time, the hazard light comes on.
the ocean's arms. Calm down.
And then next, the right turn signal and the brake can be turned on at the same time, because it was designed in a manner so there would be no interference if two functions are activated at once.